I see. Right.
Yeah.
So this accelerated testing, you're using high frequency
Vibration.
vibration.
Yeah.
It was ultrasonic, you said earlier, wasn't it? Okay. And this is essentially vibrating the, I mean, I'm not a scientist, particles, atoms, something like that?
Yeah, we're vibrating. I didn't bring any coupon. That was a shame. I forgot a specimen. It looks like an hourglass or a dumbbell.
Right.
You know, like the shape. Yeah, that looks something like that. If it is
Okay.
uniaxial, I've developed also for biaxial testing.
But this is a solid structure.
It's a solid structure,
Yeah.
piece of metal.
Okay.
Yeah.
Right.
Yeah.
And then you just vibrate that at high intensities to see what happens when it eventually fails.
It develops a crack.
Okay, I see.
And when it develops a crack, it will eventually fail. Just breaks. It doesn't shut. It doesn't explode.
That's a shame. In my mind, it's like
no, it was a crack. The crack grows, and
the crack grows, and eventually it would fall apart. I would guess.
In reality, typically, it doesn't really go down to that, because what happens is when a crack develops, the frequency decreases. So these machines are designed to operate in a certain frequency band. So it's between 19.5 and 20.5 kilohertz. So as the crack develops, the stiffness decreases. So the frequency, it's like when you have a guitar, your strings can go out of tune. And typically, the pitch never goes up, it goes down, because they become more loose.
Yeah.
They loosen
of course. Yeah.
a little bit.
Makes sense. Yeah.
So, and when they are less tight, less stiff, the frequency goes down, the pitch goes down. And with the crack developing, it's exactly the same thing. The pitch goes down, and when it reaches the 19.5, the system stops. So you then can insist to try to break it,
right.
but it would stop when the crack opens up to a certain extent.
So to I mean, I might have completely misunderstood here, but to me, there's like a machine, there's like a box that you put this metal inside in the middle.
Yeah.
And then ultrasonic waves get pumped at it. Is that right, or are they put through? No,
the machine is the specimen has a screw is screwed to a machine. Machine has what we call I don't have any picture here to show, but it has an actuator,
right,
which is actually used for welding plastics. Then it has what we call a booster, which increases the vibration amplitude, and also has the fixture where you're going to place it on the machine to be held somewhere. And then you have what we call a horn, which is again to increase the amplitude of the frequency. And then you pop the specimen there. So you have a sequence of stuff, and the specimen is here. It's being basically hung by the horn. And then what it does, the machine makes it shake like that.
Right.
You can't see it. We have machines that we have a very high-speed camera, digital image correlation camera, that you might want to see, given your background.
I'd love to see that.
It's very high speed, and we can actually watch our specimens deforming at 392 kilohertz. So we're talking about 392,000 photos per second.
Wow!
So we need to have very powerful lights, LED lights, to be able to see the deformation. We painted the specimen.
Are they LED lights?
Maybe not.
I would question that only because my knowledge of lighting is that anything that's LEDs are blinking on and off.
You have to go
50 hertz.
Okay, but you have to go and have a look.
I will have to, yeah.
You have to go have a look.
It might be an incandescent light of some sort that's just glowing.
Maybe
a filament.
I thought
because they're constant.
I thought this was LED, but we can.
That would be interesting to see.
You are obviously invited.
Oh, great! That'd be great. I'd love
to the lab to go and see.
Yeah,
it working. What it does is we spray the specimen with a white matte paint, and then we spray with black on top, or we use a brush to do a speckle pattern, black and white, and then when it deforms ever so slightly, the camera picks up the pixels moving, and you can actually measure deformation. Then you could show it deforming in slow motion. It's very interesting.